Okay.
So what I'm sharing with you now is my Firefox. So here is module 4. And you can see that today's lab is the titration of juice for vitamin C content.
Oh, I'm okay.
So
Well,
this is what I was going to talk about today, but
perfect. I'm all into it. Let's do it.
there's actually a video.
Oh, well, I'll watch a video, whatever you want to do, Tony. I'm game.
Okay, so well, let's take a look at what I have on my tabletop, because it's always good to talk about these things. So I'm going to do a new share. And now we're looking at my desk.
Yeah.
So I'm going to have to rotate the camera digitally so you can see my arm. So here I have a juicy juice box.
Okay, nice.
And if I bring this up to the camera, can you see how it says 200 milliliters right there?
Yep.
It's hard to tell. And when I flip this over, can you see how it says vitamin C 90 milligrams?
Okay.
That's 100% of your daily amount of vitamin C. And if you look at the ingredients, it says apple juice, water, ascorbic acid, which is another name for vitamin C, and citric acid. Okay, so vitamin C is not normally found in apple juice. And it's in here. So we want to see if there really is 90 milligrams of vitamin C in here using a chemical titration.
Okay.
Okay. So that's what today's lab is about. And what I'm going to show you here is also in the video, but it's kind of good to see in person. So what I have here are, not sure what these things are called, but honestly, what we do with these is we put dipping sauces in them. So when we make chicken tempura or something, we dip them in here. All right. Here I have this stuff called, it's missing a couple of numbers here. It's called 2,6-dichlorophenol indolphenol. It's a really long name, but you see how it's blue in color?
Yep.
If you were to put this on paper, it would dye it blue. So I call it dye. Fair enough?
Gotcha.
This is ascorbic acid right here. And this is a metaphosphoric acid. This is something that we'll need for the lab also. So all of that is in your packet. Now, I'm going to move this off to the side. I also have my graduated cylinder. I have my balance and a few other things. Now, what I'm going to draw for you is something that you don't want to draw right now. It's not really going to help you to draw it, but it helps me to explain what's going on. So I'm trying to get the zoom right. And then I have to make sure that it's focused. Okay, there we go. Okay, so vitamin C has a structure that looks like this. And I think we talked a little bit about these structures before, where if a bunch of lines, the lines are bonds. Did we talk about that before?
The double bonds, yeah.
Yeah. And if you don't see an atom where the bonds meet, it's a carbon.
Mhm.
So this is the structure of vitamin C. And we're going to react it with that dye molecule, which looks like this. You can see why I'm not having you draw this, because it would take you so long to draw this to keep up that
Gotcha.
we'd be done in an hour and just draw these things. So this is the dye, and you can see that it is blue, right?
Right.
But it turns out the dye is also an acid base indicator. So when it's acidic, it's red.
Okay.
When you react these, here's what happens to the vitamin C. And I'm going to point out to you the big difference between the two molecules, the before and after, that is. Can you see the big difference is right down here? There's an H.
Was an H, yeah.
There is one, and now there's not. And the same over here. So this has basically lost 2 hydrogens. And that's the difference. Now, what happens to the dye molecule? This is what happens.
Picks up the 2 H's.
You got it, Toyota.
But takes in 2 waters, or? Oh.
Nope. There's one of the hydrogens, it adds to the nitrogen, and there's the other hydrogen, it adds to the oxygen. So this is a oxidation reduction reaction. And it's difficult to notice because there's no pure element in here. And it's not that important that we know it's a redox reaction, but it is. And what happened is the vitamin C is getting oxidized and the dye is getting reduced. So here's the dye, and I'm going to put this in quotes because it's not the same molecule, because now it has 2 extra hydrogens, and this is colorless. So we're going to use this fact that the dye reacts with the vitamin C on a 1-to-1 ratio. And when it reacts, the vitamin C gets oxidized and the dye gets reduced, and it goes from a colored compound to a non-colored compound. And we're going to use that to titrate the vitamin C in the juice. I will tell you this, and this is something you don't need to know. Another sign that you've been oxidized is that you lose hydrogen. And guess what happens if you gain hydrogen? You don't get oxidized, you get reduced. So there's lots of different ways of telling if something got oxidized or reduced. Another way is look to see the change in hydrogens. If you get hydrogens, you're reduced. If you lose them, you're oxidized.
Yeah. Okay.
Another way is to look at how many oxygens change. If you get more oxygens, you've been oxidized. If you get fewer, you've been reduced. Okay, so here I have my little, I think it's called a ramekin or something like that. It's not dry, but it is clean, and there's nothing in here but water. And what I'm going to do here is I'm going to put some water in here. And normally when we're moving things around in this lab, we're going to be using these pipettes, okay? Now, I've used this pipette earlier today, and I don't know what's in it. It's wet. So that I don't contaminate things, what I'm going to do is I'm going to squeeze the bulb, and then I'm going to stick it in my water, and then I'm going to draw the water up, and then I'm going to rinse the bulb out and put that in a large coffee cup I have over here to the right for all of my used solutions. So what I'm going to do is I'm going to rinse this 3 times with the water. Okay, so now I'm pretty sure that I don't have any other stuff in my pipette. It's just water now. So on this pipette, I want to show you a couple of features. And for that, I'm going to have to zoom in. Okay, there we go. Now I have to focus. Great. So do you see the line right by my finger right here? If I rotate it around, you can kind of see it's a bulge.
Yeah.
Okay, so there's another one of those right there, now in the middle of the screen. Can you see that one?
Yep.
And now when I rotate it, do you see that 0.5?
Oh, okay.
That's 0.5 milliliters. And then there's another line here, and you can see there's no number or anything associated with it as I rotate it. And then there's one line that's right below the bulb. And do you see the number there?
What, 10 mils?
Actually, it's just one. So down here at the bottom, it says milliliters, and here at the top, it says one.
Oh, gotcha. Okay.
So the point is that this holds 1 milliliter precisely. And you can measure 1 milliliter or 0.25 or 0.5 or whatever. So now I'm going to zoom back out. Whoops, a little too far. Okay, so what I want to show you is I'm going to put 2 mils of water in here. And the reason I'm putting only 2 mils of water in here is because that's similar to the amounts we're going to be using in the rest of the experiment, okay? Okay, so there's not enough water in there to fill the bottom. Can you see you can see the liquid in there, right?
Yeah, yeah.
Not enough to fill the bottom. Now I'm going to take my dye here and I'm going to add a drop of dye to this. Now, when you use your dye, Greg, I want you to make sure that you use a fresh pipette for this, because you do not want to rinse with this stuff and then toss it out. You don't have much of it, so make sure you use a nice dry pipette with this one and never rinse it. Fair enough?
Gotcha.
Okay, so here I'm going to put a drop of dye in the water and let's see what happens.
Okay.
So no surprise, it turns it blue, right?
Right, it's neutral. Okay.
Okay, so now that's the blue dye, neutral solution. And now what I'm going to do here is I have some metaphosphoric acid, and I'm going to put in a few drops of metaphosphoric acid and look at what color it is now.
So pH has gone up.
Yeah, well, actually, it's gone down. With acid, the pH is low.
Sorry about that. My bad.
It's a reverse type of thing. Okay, so in this reaction, we're going to do it under acidic conditions to make sure that all of the dye is going to be pink when it reacts. Okay. Now here I have another ramekin, and I'm going to put a little bit of acid in there. I'm running out of acid because I've had to work out the parameters last night, and then I used a lot of it this morning. So now I'm going to put some water in here. So my 2 mils of water. I think I put a little too much in there, but that's all right. So in here now, I'm going to add a little bit of vitamin C. So here's my vitamin C container. And when I say a little bit, I'm going to show you how much I'm going to add in here. Can you see what's on the tip of my spatula?
Yep.
I'm going to add that here. And it looks like there's hardly any vitamin C there, right?
Okay.
In fact, if I measured it on a balance, it'd probably be less than a milligram.
Okay.
And there's 90 of those in that juice box. Okay, so now I'm going to add a drop of my dye to this. And I'm going to zoom in on this so that you can see this really well. Okay, so I'm going to move this over just a little bit so we can see the pink from the other one, right?
See it
And we can see the,
here on the right.
now what I'm going to do is I'm going to add a drop of dye to this. And it's blue, which means I probably didn't add enough acid. But do you see what happens to the blue color?
It's gone.
It's gone. It's like it was never there at all. Now, we saw that when we put dye in there before, it turned it pink.
All right.
Now we put dye in there, and even though I don't have enough acid in there, we would expect this to be blue, but why is it not blue? And the key to this is what I've drawn below, which I now need to zoom out on so we can see it. Ah, darn it. So in this container here, where I had a little tiny bit of vitamin C in the water, and then I added the dye, what happened was the dye that was blue in color reacted with the vitamin C and it became colorless. And the vitamin C is colorless when it dissolves in water, and when it reacts, it's still colorless. So we never did see the vitamin C. Now, what does this mean if I added one drop and it turned clear? What does it mean for the ratio of dye to vitamin C in my container? Have I used up all the vitamin C? What do you think?
Actually, we don't know if we used up all the vitamin C.
How could you tell?
You'd have to keep adding until you see a color change.
That's exactly right. And that's what we would do, is we would keep adding dye until we see a color change.
Okay.
And the deal is that you count the number of drops of dye that you have to add. And that is something you want to keep track of to do this lab. Okay, so you got kind of the scope of what things we're looking for. And now I want to give you a scope of how to make things, okay? When I say make things, you know, how to make the solutions that you have to use. So I'm going to do a new share again. And I'm going to share the lab itself. And a lot of this is in the video, but it's really good to, I think, hear it. Oops.
Oh, I totally agree.
I'm going to back out because I picked the wrong lab. I'm used to my computer being so much faster. When I have the Zoom open and my camera on and the Elmo going, my computer slows down quite dramatically because it's kind of old. I think it was made in 2015. Okay, so I'm scrolling down to titration of juice for vitamin C content. And this is due next week on Wednesday. So if you take a look for the submit, you're going to submit images of the lab write-up. And this time, the submission is going to be a text entry. Usually, I have you do a file upload.
Right.
This time, I'm going to have you do a text entry but in the text entry window, there's a place where you can upload files.
Okay.
And the place you upload files is in a place that says images.
Okay.
So you can take pictures of your files and load them up as images all into one window. And I think you guys will like it.
Okay.
And the image icon looks like a landscape icon with a mountain and a moon, or a mountain in the sun, whatever you want to call it.
Okay.
I want images of your lab write-up, images of your titrated samples on top of a piece of paper with your name neatly written. So this is, if you will, my assurance that you've done the lab instead of just taking photos from somewhere else.
Gotcha.
And mind you, Greg, this isn't just for you. This is for everybody. Oh, I'm not picking on you.
No, I don't take nothing personal.
Okay. Well, you should take some things personal, like especially if someone walks up to you and say, man, that is a nice car. I would take that personally well.
You know, I take things personally well, but if you don't pay my rent, I don't take anything personal.
Okay. And then an image of you wearing your goggle, and actually it should say goggles, as you admire the color of the dye solution.
Gotcha.
This is so that I know you're wearing your goggles, because when you use the metaphosphoric acid, you should be wearing goggles.
Okay.
I knew I didn't have any. That's why I didn't wear any goggles. So we're going to learn how to perform titrations and so forth and so on. So here, I give you a little bit of background about vitamin C. And this is another drawing of the reaction, where the drawings are a little bit different, but don't worry about that. Okay, so I'm going to scroll down. Safety, the metaphosphoric acid, it doesn't bother me one bit, but I have seen people get it on their hands and then their skin gets dry and irritated like red. So you don't want to spill the metaphosphoric acid on you if you can avoid it. And, you know, if it makes your hands irritated for some people, you know, for darn sure it could hurt your eyes, right?
Mhm.
So that's why you wear the goggles. So look at the procedure. We've got 1, 2, 3, 4, 5, and 6. 6 is a real easy one. You're going to have to get your own juice box and make sure you buy something that has vitamin C in it.
And sounds good.
And you're going to write down the volume of one serving in milliliters. So in my case, it's 200 milliliters is equal to one serving. So that's number 6. Let's look at 1 through 5. And you'll notice I use a lot of abbreviations here, like VC solution. SOLN stands for solution. VC stands for vitamin C solution.
I thought it was vodka and cola, but okay.
And DVC stands for diluted vitamin C solution. And then we titrate the diluted vitamin C solution. And then DJ does not stand for disc jockey, but rather diluted juice.
Gotcha.
And then we titrate the diluted juice. And I'm going to show you step by step how to do 1, 2, 3, 4, and 5. Okay.
Oh, great.
So you'll have to kind of bear with me because I'm working at a small tabletop and so forth and so on. I'm going to do a change share so you can see my desktop. And what I'm hoping you can see now is my balance.
Yep.
Now, what I'm looking for, I can't find, so I'm going to have to do this again. Can you see this, my little ACE rewards thing?
Gotcha.
I'm going to tear a little bit of this off. And I happen to have torn the part off that has that little gummy stuff on it, but I'm going to use the other side. And I'm going to fold it once, and I'm going to put it right there on my balance like that. And the reason I want to use this stuff is because it's kind of waxy, which means if you put a powder on it, it'll slide off pretty well. Okay. So I'm going to turn my balance on, and with the paper on there, it should go to 0. Now I'm going to take my vitamin C and I'm going to measure a certain amount and put it on the balance, but I'm going to stop for a moment. And I want to tell you that the directions say put about 125 milligrams of vitamin C on your balance, and you're going to use that 125 milligrams.
Okay.
So there you go, 125 milligrams of vitamin C. My balance doesn't measure in milligrams, so I'm going to convert this to grams.
Okay.
So this method of converting is called substitution, where I substitute 10 to the minus 3 for milli. When I work this out, I get 0.125 grams. The other way to get the number is to take the 125 milligrams of vitamin C and multiply by 1 gram of vitamin C over 1,000 milligrams of vitamin C. And when I put this into my calculator, I'll get precisely the same answer. Okay, so we know that I need 0.125 grams. Fair enough?
Yep.
So back to the balance. I'm going to make sure I have a nice clean spatula. I'm going to take a little bit of my vitamin C here and I'm going to put it right on that flyer. And it's 0.04, 0.04, 0.08, and I got 0.13. That's good enough. You know what? Because I can't get 0.125. My balance doesn't measure that. Are you with me there?
Yep.
So I am now going to take this and I'm going to add it to my graduated cylinder, like so. So I'm making sure I get all the vitamin C in there. And again, the waxy paper helps the vitamin C to slide right off. Okay? So I'm done with the waxy paper. I can recycle that now. And here I have my vitamin C solution, or my vitamin C. Now, you'll notice that my graduated cylinder seems to be wet because the vitamin C is sticking to the sides. Do you see that?
Yep.
That's not a problem.
Nope.
The important thing is I know how many grams of vitamin C are in there. That's the important thing. Now, what I'm going to do now is I'm going to take my water bottle, and I just have regular tap water in here, and I'm going to use this to squirt down the sides of the graduated cylinder. And what that is going to do is if there's any vitamin C on the sides, it'll wash it down to the bottom. Fair enough? So I'm washing down the vitamin C, and if you look down the barrel of the cylinder, can you see that little white stuff at the bottom?
Yep.
That's undissolved vitamin C. Now watch what happens when I swirl this. It almost looks like a galaxy swirling, right?
Yep.
And my vitamin C is not dissolving completely, but what will happen is I add more water, it will dissolve better. And we're going to add enough water here, a little at a time with swirling, to get around 50 mils of solution. Now, when I say 50 mils, that doesn't mean I want 50.0. It's just around 50.
But what's important is that all the vitamin C dissolve, correct?
That's the important part. So here I've gone a little bit over 50. I'm at like 51. So I'm going to make sure that this is well mixed. Now, the best way to make sure that this is well mixed is to get another container, like say one of these. This is I can already tell this is a bad idea, but I'm going to go for it, okay? So to make sure that it's well mixed, you pour this into your container and then you pour it back in. Hot darn, nothing. I'm getting it all in there. I didn't think I'd be able to pour from such a large round container back into my graduated cylinder. So you do this a couple of times.
And now you're pushing your luck.
And what you're doing is you're making sure that all that vitamin C that was on the bottom of the graduated cylinder is being dissolved and mixing with your solution. Okay, so there's my solution. Are you good with that?
Yep.
And then I'm going to pour my solution into this beaker here. Now, this beaker I prepared this morning. So we're going to pretend that this is the solution I just made. Now, for this beaker here, I'm going to use a pipette. And if I haven't used a pipette, or if this pipette is wet, how can I make sure that I don't contaminate this solution with whatever's in the pipette?
Flush it out 3 times with water.
That's right. So 1, and I like to turn the pipette upside down so that the whole bulb gets rinsed out.
Now, shouldn't you clean it in water before you put it into your solution?
You can, but it's not really necessary as long as when you stick it into your solution, you don't squeeze the bulb.
Gotcha.
So if you squeeze the bulb and there's stuff in there, you'll squeeze it into your solution. But if you squeeze the bulb before you stick it in your solution, when you release the bulb, it just sucks solution into it, so there's no cross-contamination. But on the other hand, Greg, what you're talking about is actually a good idea. You know, you want to be careful. Okay? So here's that solution that I just made, and that solution I made by dissolving 0.13 grams of vitamin C, and I'm going to convert this to milligrams.
Okay.
So I just used 130 milligrams of vitamin C. That's how much I used. And that 130 milligrams of vitamin C was in 50 XZ milliliters of vitamin C solution. So we want X and Z to be, you know, small numbers. We don't want X to be like 59. But if it ends up being 59, that's fine. Don't remake your solution. That'll work. Okay? And we should be able to read our graduated cylinder to the 10th. So that's why I have the Z here. And of course, these two numbers do not have to be the same. That's why one's X and the other's Z. So are you good to go on that?
I'm right there with you.
So that's number 1. That's the first part. Now let's look at the second part here. And I'm going to go back to the description. So here, number 1, we've just made that solution, and this says it should be X milligrams, which should be close to 125, and Y milliliters, which should be close to 50.
Okay.
Now for number 2, here's what you're going to do. You want to take your graduated cylinder and rinse it out with water. And so what you're doing now is you're removing any of that vitamin C solution from your graduated cylinder. And you can take this to the sink and rinse it 3 times, or, you know, for me, I don't want to walk away from the table, so I'm rinsing it with my bottles of water. And you just want to make sure you rinse the sides down, and the rule of thumb is 3 times, okay? Now I've got my rinsed graduated cylinder. So this says take 1 milliliter of your vitamin C solution and put it in here. Add 10 milliliters of metaphosphoric acid. It says about 10, not exactly 10. So it turns out that if you only put 8 in there, you're going to be fine.
Okay.
Okay. If you put 12 in there, you're going to be fine. If you put 20 in there, that's bad. And I'll tell you why. You only have about 20 milliliters and you need to use the metaphosphoric acid twice. So if you use all 20 right now, you don't have any for later. So roughly speaking, you use half of your metaphosphoric acid now and half later. Are you good with that?
Yep.
Okay, so I'm now going to do a switch screen so you can see what I'm doing. So here's the solution we just made. Here's my graduated cylinder. I'm going to get 1 ml of solution in my pipette, and then I'm going to put it in my graduated cylinder. And then I'm going to take my metaphosphoric acid. So here's my metaphosphoric acid, and I'm going to put 10 mils in there. And when you put 10 mils in there, all you really have to do is look at the bottom of the graduated cylinder. If it comes up to about 10, then you have enough. Does that make sense?
Yep.
And then I'm going to add water. And this time you're going to add enough water to get close to 100. Don't try to get 100 exactly because it's too hard to do. And it's actually bad technique. So I'm going to put water in here and I'm going to get a final volume. And my final volume is like 98 milliliters, 98 point something. Okay, so here, it seems like this would be well mixed, but it's not. So I'm going to get a dry container. And how am I going to mix this?
Slush
The
it
same way I did before. Pour it back and forth. I don't think I'm going to be successful this time. Yep, I messed up. So I've just given you an example of what not to do, haven't I? But luckily for me, I did this successfully this morning and it's in this container.
Perfect.
I feel like I have real production value here because, you know, on TV, they're never doing anything perfectly, but it always comes out really just great. So I'm going to do the same thing. So here's the solution I made. And this is my dilute vitamin C or DVC solution. So that's number 2. So number 1 was 130 milligrams of vitamin C is equal to 50, I'm going to just call it 51.1 milliliters of vitamin C solution. And this number here, 51.1, is a number I just made up, okay? And you might be wondering, so why write that number, Tony? The idea is to give you an idea of about how much you should have.
Okay.
I'm focusing it because it looks like it was a little out of focus. Okay, that's better. Number 2, we took 1.0 milliliters of our vitamin C solution. We added metaphosphoric acid, which does not change the amount of vitamin C in there. And we added water to get to a final volume of whatever, and it doesn't change the amount of vitamin C in there. And we get, I'm going to say 98.8 milliliters of DVC solution. So that's number 2. Any questions about the first 2 parts?
Nope.
Okay, number 3, you're going to get a clean container, doesn't need to be dry. And for the container, I like to use something where it'll be easy for me to see the color. So if you use a colorless container like a glass, it's best to put the glass on something white so you can see the color against the white background. since I'm using these white ramekins, I don't need the a piece of paper underneath it, even though I do have one. So I'm going to take this solution and let's take a look at number 3, okay? A lot of back and forth here. So number 3, I'm not going to let you read this in detail, but basically it says this: take 2 milliliters of your dilute vitamin C solution, put it in a container, and then titrate it with the dye.
Okay.
So guess what I'm going to do with my pipette, which may need to be rinsed.
You're gonna rinse it.
I'm going to rinse it 3 times. So I've already done that. I'm going to get my 2 mils. I want to be try and be careful. 1, 2. Okay, there's my 2 mils. And now I want to titrate this with dye. And let's see what happens when I start adding dye. So here's 1 drop. And you see how it hits and it turns blue and then pink right away? It's blue because, of course, it's blue colored. Oh, I just added another drop. And what I'm going to do here is I'm going to titrate this till this turns pink and stays pink. And you can see it doesn't look like it's stained pink yet. Now, what I'm going to do is I'm going to take this off camera. And I'm adding more drops in. And the reason I'm taking it off camera is because I don't want you to see how many drops it takes.
Because?
Because I want you to do the experiment yourself.
Oh, okay. You don't trust my pictures, Tony?
I don't know. For all I know, you may just take a little ramekin and put a little food dye in there.
You know, that's possible.
You're a smart guy. I know that. Okay.
It sounds like almost as much work as the experiment, but yeah, go ahead.
Do you see how that's not pink yet?
Right. How many
Now, the
drops?
reason I'm showing this to you is that when I put the last drop in, it seemed to take a little while to change from pink to colorless. So I'm thinking it may take 1 more drop or 2 more drops, and then it'll be pink.
Put it under the camera. I don't know how many drops you put in.
Yeah, right now you don't know how many drops, but do you see how with 1 more drop?
Is it pink right now?
What do you? Hard to tell.
It looks like, for me, it looks like it's turning pink.
Yeah, it's hard to work with the cameras here. You can tell I do not have a degree in camera technology.
So if you did 1 more drop, we'd get darker.
Well, let's find out.
Yeah.
Definitely.
Okay. So that's
So I would probably count that drop and say that counts, but would you say that that's definitely pink?
That's definitely pink.
Now, if I add another drop, it probably won't get any darker.
Let's
find out. And it's not really, I guess it's a little darker, but not that much. Okay, so that's titrating it to the endpoint. And we're going to assume that at this particular time, the number of molecules of vitamin C equals the number of molecules of dye that we added.
Okay.
Okay.
Okay, that sounds good.
So for number 3, we're going to write 2.0 milliliters of dilute vitamin C solution is equal to, I'm going to call this
X number of drops.
Well, I already used X before, but yeah, why not? X drops of dye. And that's number 3. Number 4. And before I move on, I want to show you just with these 3 things what I can do. So I'm going to cross off number 4 here, and I'm going to write 130 milligrams of vitamin C, and this should say, no, that's correct, 51.1 milliliters of vitamin C solution times, I'm going to use this conversion next, and the reason is because I want to cancel milliliters of vitamin C solution. So I'm going to put 98.8 milliliters of, oh, excuse me, 1.0 milliliters of vitamin C solution on top, and 98.8 milliliters of dilute vitamin C solution on the bottom. And so I get to cancel my milliliters of vitamin C from here and here. And then I'm going to use this last one here, and I'm going to have 2.0 milliliters of dilute vitamin C on top solution and X drops on the bottom. And when I do the whole calculation, I can't do anything about the X. Let's pretend X is 10 for just a moment, okay?
Mhm.
So I'm going to put 10. Let's see what we get. And we can even estimate the answer, right? Because let's see, 2 goes into 98.8 50 times. 50 goes into 130 2.5 times. 2.5 times divided by 51 and also divided by 10 is going to give me a number that's really a lot smaller than 1. So that's my estimate. A lot smaller than 1-ish, okay?
Mhm.
And I get 0.0051 milliliters of, excuse me, that cancels, of milligrams of vitamin C per 1 drop. Now I use 10 in this case, okay?
It'll be X drops.
Well, I use 10 for X. That's why I have per 1 drop here.
Okay.
So I just use 10 as a pretend number. But if you take a look at this, this tells me that if I add drops of my dye, to any container that has vitamin C in it and count the number of drops till it turns pink, I can then use this to figure out how much vitamin C was in there.
Huh.
Does that kind of make sense?
Yeah.
So if I have a container and I add 2 drops, it means I have 0.0102 milligrams of vitamin C in there. So this is a pretty sensitive test, wouldn't you agree?
Okay. I understand. Yeah.
And if it took 3 drops, it'd be 0.015 milligrams in there, and so forth and so on. Okay. Now, the next thing. Number 4 is working with the juice. We're going to dilute it. And for the juice, I'm going to poke a little hole in the top, and I'm going to rinse my pipette 3 times with the juice. Now, if you have kids running around, you don't want to let them drink this juice box when you're done, because you're sticking a pipette in there and it's chemistry. Fair enough?
Yep.
But on the other hand, if you do want to let the kids drink the juice box,
Like if I don't like my kids.
if you like your kids and you want them to be able to drink the juice that you're not going to use, you're going to need 2 milliliters of this juice plus enough to rinse your pipettes.
Gotcha.
So you could poke the hole in here, squeeze most of the bottle out into a glass. Actually, I got a better idea. Poke the hole in here, squeeze enough into a glass for you to use, and give them the juice box with the straw in, and they're going to be happy.
Gotcha.
You're going to be the world's greatest dad.
Yeah, my 20-year-old son will appreciate that.
Yeah, I got a 30-year-old and a 25-year-old. So I'm with you. I get it. And mine still like juice boxes.
Yeah, mine likes alcohol.
My kids don't do any of that stuff. I guess I should be really proud of them, but at the same time somewhat disappointed.
You know, I'll talk to you offline.
Yeah, so I'm glad that they don't do any drugs or drink. That's great.
Yep.
But I guess what I'm saying is, you know how they say the apple doesn't fall far from the tree?
The apple missed in your case?
In this case, my apples, my kids, fell from the tree and rolled down the hill.
But mine rolled in a good direction.
Yeah.
I couldn't be more proud.
Yeah, mine rolled in a good direction because the tree wasn't so hot.
Yeah. I concur.
Okay, so here I have my graduated cylinder, which I've rinsed out with water. And now I'm going to put 2 mils of juice in here. 1, 2. And now I'm done with my juice box. And I don't know why I have this here. I guess just for show. Now, do you remember how I said you're going to use the other half of your metaphosphoric acid later?
Mhm.
This is the time. So you're going to put in your 10 mils of metaphosphoric acid. So you pour it in there. And then you're going to add water. And again, you want to get close to 100, but not exactly 100. And whatever number you get, you just measure it.
Mhm.
And then, you know what I'm going to do with this next, because it's not mixed well, I'm going to mix it well.
But you're going to pretend to, and you're going to show me a solution that's already mixed, right? Good production here. That's what
You
we're
know me
for.
so well.
Good production, right? Yeah.
And so here we go. I have mixed the solution really
Perfect.
well.
Perfect. And no mess. Wow, I'm impressed.
You should be. I mean, not only did I mix this really well, but I already rinsed out the pipette 3 times.
Nice, nice. Okay.
Okay.
You're making it hard for your students to, follow this, but go for it. Yeah.
What do you mean? You already told me what I did before I did it.
Got it. Got it.
So now you're going to take 2 mils of this. 1, 2. And guess what you're going to do?
Titrating.
Titrate it with my dye. Now, I know I don't have enough dye to make this change, but I'm going to give it a little try. So there's 1 drop. You see how it turned pink?
And now it's gone. Yeah.
Now it's gone. Another drop. Another drop. And
now you're out of.
But on the other hand, you see how long it took that last drop to disappear?
Yep.
And I can tell that it is slightly pink, but we want it to match the pink that we had before. How can I make sure that it matches the pink I had before?
Keep the sample.
Keep the sample. Okay, so I can tell that this probably would do it with 1 more drop. And you want to record that, and that's number 5. So number 4 is going to be 2.0 milliliters of juice solution is equal to, I'm going to call it 95.5 milliliters of dilute juice solution. So J stands for juice, DJ stands for dilute juice. And then number 5, you take your 2.0 milliliters of dilute juice solution and you find out how many drops it takes. So let's just say it's 5 drops. Okay, so these would be the numbers that we would want to use for our calculation to find out how much vitamin C there is in a serving. And there's one more thing here. We want 1 serving is equal to 200 milliliters of juice. Now, the reason I put a point there is because they have 6.75 fluid ounces, and that has 3 zig figs. So the 200 should also.
Okay.
Are you okay with that?
Yep.
And this is, of course, on the box. So I'm going to start with 130 milligrams of vitamin C over 51.1 milliliters of VC solution. And what I'm going to ask you to do for me to help me out is tell me how I'm going to use this second one next to this guy.
So it'd be, you used above you 1.0 milliliters of the, man, I don't know, VC. That was vitamin C.
Vitamin C.
Over 98 or the diluted vitamin C. So on this one, you're going to use
So like that.
1 mil. Oh, okay, same way. Yeah,
Now, how am I going to use this number 3?
you're ahead of me. Hold up.
No worries. When you catch up,
it'd be 2 milliliters of dilute juice over with 5 drops.
no, we don't know. We don't want to use 5 yet. We want to do number 3.
Oh,
The reason we want to use number 3 is because you see number 3 says dilute vitamin C,
mhm.
and we want to cancel that dilute vitamin C.
Oh, that's okay. 1.0 liters C solution over 0.8 milliliters dilute vitamin C. So you can multiply times 2.0 milliliters dilute vitamin C on top. Milliliters dilute vitamin C on top.
And we're going to let's put 10 drops.
Okay, 10 drops.
Even though I did that off screen and you don't know how many it took.
Okay.
So here, I'm going to put questionable. Okay, now let's look at these other ones that we have for number 4, 5, and 6. Do you see how we have drops of dye on the bottom?
Mm-hmm.
We want to cancel that. So do I want to use 4, 5, or 6?
To get rid of the drops on the bottom.
Yeah.
Use 5 drops of dye. So number 5.
So 5 drops of dye on top, right?
Right.
And what goes on the bottom?
2 milliliters of dilute juice solution. 2.0 milliliters dilute juice solution.
Okay, so now we've gotten rid of the drops of dye. How do we get rid of the milliliters of dilute juice solution?
Oh, God, wait a minute.
It's almost like a game of seeing what matches up with what.
Dye with 2.0 dilute juice solution. And I want to get rid of dilute juice solution now.
Yeah. Our ultimate goal, Greg, is to get serving on the bottom.
Well, we got, if we want serving on the bottom, we got 2 milliliters of juice solution. I want something that goes to juice solutions.
But I want to get rid of my DJ, don't I?
Oh, so use number 4.
Right.
95 milliliters DJs. Yeah, okay.
95.5 milliliters of DJ solution divided by 2 milliliters of juice solution, right?
Yeah.
And now we can get that serving on the bottom, can't we?
Right. Now it'll be 200 milliliters juice solution on top, 1 serving on the bottom. Shit.
Okay, so let's see what these numbers come out and tell us.
Okay.
So the way I do this is I do 130 times 2 times 5 times 95.5 times 200. And then I say divided by 51.1 divided by 98.8 divided by 10 divided by 2 and divided by 2, and I get 123. So really 120 milligrams of vitamin C per 1 serving. And what does the box say on the side per serving?
200.
I'll show you.
Here, give me a second. I'm still writing.
Oh, that's our, oh, shoot. I'm tilting my juice box and it's spilling.
Just don't wipe the stuff on the bottom off. Dilute juice. Juice times.
So on the side of the box, it says 90 milligrams. So what do we think about this titration? Considering that we're using plastic pipettes, we're measuring 1 milliliter with a plastic pipette. We've only done this one time. We haven't done it multiple times for consistency. What do you think?
Sorry, I just finished writing your equation out.
Okay. So the results are 120 milligrams when it should be 90.
Okay.
What do you think of this titration method?
I disagree. Shouldn't the pipette be pretty good at it? I mean, we do have to run it over a couple more times, but blaming it on the measuring equipment, the pipette that's a measured amount, right?
It is a measured amount, so it's not exact.
Okay. Well, yeah, pipette and do it 5 more times. We'll get closer.
Yeah. You're not going to have time to do it 5 times. You might have time to do it 1 more time, but if you do it once, that's fine. But I think what we should be saying here is that, you know, this is in the realm of possibilities for the juice.
Mm-hmm.
You know, we didn't get some outrageous number like 9,000 milligrams.
Okay.
We got 120. So
we're off like 30%.
Yeah, we're off by like a third.
Yeah.
And who knows, maybe they put a little extra kick in there because the guy putting the vitamin C lost track. Who knows?
Gotcha.
Okay, so I'm going to go back to the new share and we're going to look at the lab. So can you see here with the data, you need to present the relevant data. And the relevant data is basically 1, 2, 3, 4, 5, 6, right?
Yep.
You need to show the calculation. I also want you to do a percent error calculation, and you can look in the book to see how to do a percent error. You said that this one was off by about a third.
Yep.
And so this one would be about a 33% error.
Right.
And the results are, of course, are going to be how many milligrams are per serving from the experiment.
And then what I calculated and the difference of.
Yeah. And then you discuss, you know, why is it different?
Okay. Awesome.
And if we take a look at what I want you to submit, you'll notice that there, or maybe you won't notice, but I'm going to make you notice, is that there is no assignment. It's the lab.
Cool.
So you put your introduction. You'll notice with my introduction, I talk about scurvy. You don't need to talk about scurvy in your introduction.
Oh, I just had to talk about that.
You know, this is kind of like, oh, here's an interesting fact.
Gotcha.
What do you think you want to have in your introduction? Well, for me, I'd want to put the reaction in there. And if you don't want to draw the structures, that's fine. You should write down vitamin C plus dye gives you reacted vitamin C plus reacted dye. And then what you should also do is say that the vitamin C is colorless in solution. The dye is going to be red in solution. And the reacted dye will be colorless and the vitamin C will be colorless. Are you kind of with me there?
Yes, sir.
I mean, it would be great if you drew these structures out, but I'm not expecting it.
Good.
But you should write down the words like here, ascorbic acid, colorless.
Mm-hmm.
Oxidized form of, we didn't call it DCP, we called it dye, right?
Mm-hmm.
And so the words would be nice. And then you talk about how you're going to do a titration to figure out the concentration. For the procedure, I think you want to put all of this in your procedure, but I'm going to be honest. Some of these things that I put in here because we're a beginner class, and you wouldn't put them in a procedure in a lab notebook.
Okay.
So for instance, you wouldn't say to another student, use a magazine that has waxy paper to weigh your solid.
Got it. But I would tell you how much I weighed out, how much liquid I used.
Exactly. What you would do for number one is you'd say, I dissolved 0.13 grams of vitamin C in 52.42 milliliters of solution.
Yeah.
And you wouldn't say mixed or anything like that. Your procedure would be one sentence for number one.
Gotcha.
And number two, you wouldn't say dilute the plastic thing 3 times. You'd say 1 milliliter of the vitamin C solution was mixed with 10 mils of metaphosphoric acid to a final volume of, I don't know, 95.1 milliliters of dilute vitamin C solution. The point I'm trying to make, Greg, is that for these directions, 1, 2, 3, 4, 5, they should be pretty short and succinct.
Got it.
Okay.
Got it.
And the data, I usually, in this case, since the data is basically gleaned from the procedure, I just write all those equivalencies in the data.
Okay.
And then the calc, we've already done the calc together once, so you know how to do that. And there we go. So this one should be kind of fun, I'm hoping. And this is your introduction to titrations.
Perfect.
All right, Greg, thanks for calling in. I appreciate it. It's always much better when I'm talking to someone instead of myself.
So I will see you again Monday night.
Yes, I will be Zooming Monday night.
I'll see you then. Thank you again, Tony. Appreciate it. Have a good weekend.
Yes, you have a good weekend as well.
Bye-bye.
Bye-bye.